We present multimodality-guided image style transfer using cross-modal GAN inversion. First, I'd like to briefly introduce the image-guided image style transfer, IIST, which is the traditional research topic of image style transfer, IST. For image style transfer, we focus on applying specific style patterns to a given content image. When considering image-guided image style transfer, the style pattern is typically a style image. This style image should exhibit certain styles, such as Van Gogh's Starry Night. Effective methods for image-guided image style transfer have been well established. The foundational work by Gades et al. Introduced the initial method for IIST. Their approach involved running an optimization process using one content image and one style image to produce the stylized image. To enhance efficiency, researchers developed methods involving training a feed-forward network for each specific style. This innovation allows for the rapid stylization of new content images using a pre-trained style, requiring only a single forward operation. Building on these advancements, Wang and Belongi introduced the concept of arbitrary style transfer. They invented the adaptive instance normalization module, which enables the use of a single trained neural network to stylize a content image using any chosen style image, regardless of its specific characteristics. More recently, several methods propose to stylize images purely conditioned on text descriptions, achieving the text-guided image style transfer, TIST. These approaches commonly utilize large-scale image-text pre-trained models, such as CLIP. They leverage these models to generate visual patterns corresponding to textual descriptions. For instance, by using the multimodal embeddings of CLIP, these methods can produce visual patterns that resemble fire when guided by the text descriptor, fire. Here are some recent TIST methods. To stylize the content image, ClipStyler employs a lightweight stylenet trained using a patchwise clip loss derived from the style text description. Diffusion Clip, primarily an image editing method guided by text, also has the capability to perform TIST. Both methods are good for certain style but sometimes introduce unintended local patterns into the stylized images. In this paper, we focus on improving the performance of TIST. Furthermore, we generalize the scope of both TIST and IIST to introduce a new concept, Multimodality-Guided Image Style Transfer, MMIST, which emphasize the importance of receiving multimodal style references. More specifically, an MMIST method obtains style references from any number of style images and style text descriptions. It's worth noting that both style images and style text descriptions are optional. In other words, MMIST should also be compatible with single-modal style input. MMIST features a unified approach to handle multimodal style references in a flexible way. It also delivers improved performance on the visual quality of the stylized images. This diagram illustrates our method for MMIST. It takes as input the style images, style text descriptions, and a content image. Our method simply outputs the stylized image. The core idea of our method is to use cross-modal GAN inversion to generate style representations. Then use an adapted IIST method to stylize the content image according to the generated style representations. The cross-modal GAN inversion plays the most important role in our method. It is responsible for generating unified style representations from multiple multimodal sources. Cross-modal GAN inversion, as its name suggests, is a method of GAN inversion. However, unlike traditional GAN inversion methods, this technique aimed to reconstruct the styles instead of the contents. Moreover, it stands out for its ability to summarize the styles from multiple sources. It focuses on optimizing the latent vector in the W+ space of StyleGAN. To ensure that only the style information is considered in this optimization, we employ techniques like patch cropping and patch augmentation. Furthermore, we've introduced the style-specific clip loss, a key element in achieving cross-modal inversion. The style-specific clip loss is a generalization of the existing directional clip loss. As shown in the upper right diagram, it encourages the similarities between these three directions in the multimodal clip embedding space. The simple text prompt a photo to the style text description. The source image patches to the style image patches. And the source image patches to the style representation patches. Note that only the style representation patches are mutable during the cross-modal GAN inversion. This loss can help generate a style representation that effectively summarizes the input styles from all modalities. In addition, since the cross-modal GAN inversion is stochastic, we also apply multi-style boosting, which generate multiple style representations for a better coverage of styles. In the last step, we adapt an existing IIST model to accept multiple style image inputs, utilizing the generated style representations to stylize the content image. By caching these style representations, we eliminate the need to redo the cross-modal GAN inversion for each new content image. This allows for a streamlined process where only a single-step inference with the adapted IIST model is required, greatly simplifying and accelerating the style transfer process for new images. Since our method is the first method that support MMIST, we make most comparisons on the TIST task. Here we show the qualitative comparison with some TIST methods. Our method delivers more accurate styles than others and better preserve the content information from the input content image. We also conducted a large-scale user study on the TIST task. In this study, we utilized 44 text-described styles and 61 content images, generating a total of 2,684 stylized images. We asked 10 different users to evaluate each stylized image, resulting in 26,840 individual responses for each method. The users were asked to answer 3 binary questions, good or bad, focusing on 3 aspects of the stylized images. These aspects are the style consistency with the style text description, the content preservation based on the input content image, and the overall visual quality. The bottom table shows our quantitative user study results, including the number of positive responses and its percentage. We also show some qualitative MMIST results of our methods. Please see more high-resolution results in our paper and supplementary material. In addition, we show more examples of MMIST results from 4 style sources. We showcase stylized images with varying style interpolation ratios derived from these 4 styles. This flexibility in arbitrary style interpolation is conveniently attained by adjusting the loss weights in our style-specific clip loss. Here is another example. Thank you for listening to this presentation.